When you think about the largest animals that have ever lived on Earth, well, your mind probably jumps way back, right? To the dinosaurs.
Yeah, absolutely.
Huh.
You picture maybe a T-Rex or those enormous long-necked ones, the titanosaurs like Patagotitan.
Exactly. Creatures so big they almost defy imagination. We sort of assume that was peak size on this planet.
We do.
Yeah.
But here's the thing. The research we've looked at, it points to something, well, frankly, astonishing.
Which is?
The largest known animal to ever exist isn't some fossil dug out of the ground.
Oh.
No, it's alive right now, swimming in our oceans. It's the blue whale.
Wow. Okay. So the biggest creature ever is here with us today. That completely reframes things.
It really does.
Yeah.
And that's our mission for this deep dive, isn't it? To get past just saying, it's the biggest.
Right. We want to understand how.
Exactly. How does the biology, the physics, even allow a mammal to get this unbelievably massive? We're going to explore the adaptations, the evolutionary tricks, the sheer scale of it all.
Okay, let's start with the basics, the sheer size. The numbers themselves are just staggering. A big blue whale can be over 30 meters long.
30 meters. It's hard to even picture.
Yeah.
Like maybe 20 average people lying head to toe.
Something like that, yeah. But honestly, the length is almost secondary to the weight. We're talking routinely over 190,000 kilograms.
Which is, again, a number that's hard to process.
Yeah.
One source had this comparison that just stopped me in my tracks.
Oh, yeah. What was it?
Okay, try to picture this. Think about every single direct ancestor you have, going all the way back to the year 1700.
Right. Great-great-great-great-great-grandparents, all of them.
All of them, up to today. Now, imagine you could somehow weigh all those people together.
Okay.
A single large blue whale weighs about the same as all of those people combined, plus, like, another 450 extra people thrown in.
That's actually mind-bending. One animal weighs more than centuries of my family tree.
See, it puts it in perspective, doesn't it? And that sheer mass is why it holds the title. The fossil record, as far as we know it, shows nothing bigger. No dinosaur, no ancient sea monster comes close to that weight.
Incredible. All right, let's dive into the anatomy, a kind of body scan of this behemoth. What about the flippers? They must be enormous.
They are about 3 meters long. Think like the length of a small SUV.
Wow.
But here's the interesting part. For a body that huge, 3 meters is actually relatively small.
Really?
Yeah, it's only about 12% of their total body length. Compare that to, say, a humpback whale, whose flippers can be a third of its body length.
So blue whales aren't built for fancy maneuvering then?
Not really, no. Their design is more about efficient straight-line travel for feeding.
Yeah.
Less underwater acrobatics, more streamlined efficiency. And remember, structurally, those flippers are basically modified hands. An X-ray shows the finger bones. It's quite clear.
Okay. And their eyes. Biggest animal, surely we have the biggest eyes.
You think so, right? Their eyes are big, about the size of a mini soccer ball. Much bigger than ours, which are smaller than golf balls.
But not the biggest overall.
Nope. That record goes to the giant squid. Their eyes are like basketballs.
Basketballs? Why so big?
Because they live and hunt in the deep, deep ocean, where it's almost totally dark. They need massive eyes to capture every possible photon of light. Blue whales feed closer to the surface, so they rely more on other senses, especially sound.
Ah, sound. Which brings us to the heart and the circulatory system. There's some wild stories about those, aren't there? Like swimming through arteries.
Yeah, definitely some myths floating around. You absolutely cannot swim through their arteries.
Okay, good to know.
But the reality is still pretty impressive. The heart itself, it weighs around 180 kilograms, maybe stands 1.5 meters tall. That's like, what, 640 human hearts combined?
What?
And the main arteries, like the aorta. Well, you can't park a car in there or swim. You could probably push a volleyball through the biggest ones quite easily. Maybe an Olympic gymnast could squeeze through. They're massive pipes for sure.
Huge pipes, pumping blood for a huge engine. And that engine powers incredible sound production, right? They're supposedly the loudest animals on Earth.
They are capable of making the loudest sounds, yes. As loud as a jet engine taking off, potentially.
How do they even do that?
Well, interestingly, they don't have vocal cords like we do. Instead, they have this specialized U-shaped structure in their larynx, a voice box, that presses against fatty muscular tissues. That creates the sound.
And these sounds travel far.
Incredibly far, thousands of kilometers through the ocean, and a lot of it is infrasonic.
Infrasonic, meaning?
Meaning the frequency is too low for human ears to actually hear it as sound.
Yeah.
But if you were close enough, you'd feel it, like deep vibrations passing through you.
Why use sounds we can't hear?
Because low-frequency sound travels much, much farther in water without losing energy or getting distorted. It's perfect for long-distance communication across vast stretches of ocean, coordinating, feeding, finding mates, navigating.
So they have this immense power for sound, this huge circulatory system, but then there's this massive contradiction, right? Their throat.
Ah, yes. The great paradox of the blue whale. Here you have an animal that's, what, 2,500 times heavier than a human?
Roughly, yeah.
Yet its throat is only about 10 to 20 centimeters wide. Our throat is maybe 2 centimeters wide, so theirs is less than 10 times bigger than ours, despite the colossal size difference.
That seems impossible. How does that even work? What can they possibly eat?
It dictates their entire diet. They can only swallow very small things, primarily tiny crustaceans called krill.
Krill, those little shrimp-like things, they're only like, what, a centimeter or two long?
Exactly. The largest animal on the planet survives by eating some of the smallest prey available in huge quantities.
Okay, how do you get enough energy from tiny krill to power a 190,000 kilogram body?
Through incredibly efficient filter feeding. They're baleen whales, remember. No teeth.
Right, the baleen plates, like a giant sieve.
Precisely. Made of keratin, like your fingernails.
Yeah.
So when they find a dense swarm of krill, they accelerate, open their mouths incredibly wide.
The famous lunge feed.
That's the one. Their lower jaw has these pleats, folds of skin, that expand like an accordion. This allows them to engulf an enormous amount of water in krill, maybe up to 70 tons in a single gulp.
70 tons of water and krill.
In one mouthful.
Yeah.
Then, their massive tongue pushes upwards.
Squeezing the water out.
Exactly. Forces the water out through the sides, through the baleen plates, which act like a filter, trapping all the krill inside. Then they swallow the krill.
And they must eat a lot of krill doing this.
An unbelievable amount. Estimates suggest upwards of 14,500 kilograms of krill every day.
That's what's the comparison? Like 3 adult elephants worth of food. Daily.
Yeah. Something like that, yeah. And if you scale that up over an 80 or 90-year lifespan, our sources estimated it could be close to 100,000 elephants worth of krill consumed in the lifetime. It's just an insane caloric processing machine.
That sheer efficiency must be the key to their size.
It absolutely is, and it ties directly into their evolutionary story. Blue whales, and baleen whales in general, evolved from earlier toothed whales, more like dolphins or sperm whales.
So what changed?
Baleen filter feeding was the game changer. Think about a toothed whale, like a sperm whale hunting giant squid. It takes a huge amount of energy to chase down and catch large, fast prey. There's a limit to how big you can get with that strategy because the energy cost of hunting is so high.
Right, diminishing returns.
Exactly. But baleen whales, they swim into a dense cloud of krill which doesn't swim away fast and gulp down potentially 10 million calories in one go. The energy input versus output is massively skewed in their favor. It broke the size barrier.
And this huge size increase, this gigantism, it happened relatively recently in evolutionary terms, like the last few million years.
That's right. And it seems to be directly linked to the ice ages.
The ice ages, how?
Well, the cycles of glaciation and melting caused massive amounts of nutrient runoff from the land into the oceans. This super-fertilized certain areas, leading to enormous, predictable, seasonal blooms of krill.
Ah, so the ice ages basically created reliable krill supermarkets in the ocean.
Precisely. These dense, predictable swarms made the high-energy lunge feeding strategy viable. The whales could count on finding enough food in specific places at specific times to make investing in such a massive body size pay off. Without that reliability, the whole system probably wouldn't work.
And underpinning all of this is the fact that they live in water.
Absolutely fundamental. Water provides buoyancy. It effectively cancels out gravity's constraints. A land animal that big would need an impossibly dense skeleton and musculature just to support its own weight.
Which is why seeing a beached whale is so tragic. They literally can't survive out of water.
They can't. Their own immense weight crushes their internal organs. It causes severe crush injuries. Even if they're returned to the water, they often die later.
Why is that?
Because when the pressure of the water returns, toxic byproducts from those damaged tissues get released into the bloodstream, and it can be fatal. They are perfectly adapted for the ocean, but incredibly vulnerable outside it.
So back in the ocean, how do they find these krill patches consistently? The ocean's enormous.
It requires amazing navigation and timing. Scientists track them, partly by listening to their songs, and they've found whales will adjust their migration timing significantly, sometimes by months. Just to hit those peak krill abundances, they have to be incredibly precise.
It's a high-stakes game of finding food.
Absolutely. Their energy needs are colossal. They can't afford to miss those feeding opportunities.
Before we get to the babies and conservation, you mentioned a funny story about dolphins, annoying relatives.
Oh, right, the Terciops incident. Yeah, researchers saw this blue whale being followed persistently by a big group, like 25 bottlenose dolphins,
Happening what?
just kind of buzzing around his head, seemingly harassing it.
Yeah.
The idea, based on seeing similar things with birds like frigate birds chasing gulls, is that the dolphins might have been trying to annoy the whale into throwing up some of its krill so they could steal it.
Huh. Even the biggest creature on Earth has pests to deal with.
Apparently so.
Okay, let's talk about the next generation. Blue whale calves. They start big, right?
They were born huge.
Yeah.
Definitely the chunkiest babies on Earth, as one source put it. And they grow incredibly fast.
How fast?
They drink around 200 liters of milk a day. And this milk is super rich, about 50% fat, compared to maybe 4% for human milk.
50% fat. Wow.
Yeah, and that allows them to gain something like 90 kilograms. That's 200 pounds every single day.
That's staggering growth. How does the nursing work underwater?
It's pretty neat. Because the milk is so thick and fatty, the mother can essentially squirt it into the water near the calf's mouth. And it doesn't just dissipate. The calf can drink it without swallowing too much seawater. It's like underwater condensed milk almost.
Clever adaptation. Now, beyond just feeding themselves and their young, blue whales play a really important role in the ecosystem, don't they? Like ocean gardeners.
That's a great way to put it, yeah. This is a fascinating discovery. They tend to feed down deep, where the phytoplankton and krill are often concentrated.
Okay.
But they usually defecate near the surface, and their droppings are enormous and incredibly rich in nutrients, especially iron, which is often limited in surface waters.
So they bring nutrients up from the deep and fertilize the surface?
Exactly. Their poop acts like fertilizer, boosting the growth of phytoplankton, the base of the food web, and consequently, the krill that feed on the phytoplankton. They're essentially helping to cultivate their own food source.
That's incredible. They're farming their own food. It allows them to stay in one productive area for longer too, right?
Yeah, maybe for 1.5 to 2 months sometimes, really maximizing their intake while the conditions are good. They are truly ecosystem engineers.
So protecting them isn't just about protecting one species, it's about protecting a key process in the ocean. And how are we doing with protecting them? What are the modern challenges and research methods?
Well, research has come a long way. Scientists now use sophisticated tags like GoPros, combined with GPS and sensors, to get a whale's point of view. It helps understand their diving behavior, feeding strategies, migration routes.
That sounds amazing. But the threats are still significant.
They are. The biggest direct threats are still collisions with large ships, vessel strikes, and getting entangled in fishing gear.
Right.
But then you also have broader issues like chemical pollution, plastic pollution, climate change impacting krill populations, and underwater noise pollution.
Noise. That comes back to their infrasonic communication, doesn't it?
It does. Increased noise from shipping and other human activities can mask their calls, making it harder for them to communicate over long distances, find mates, coordinate feeding. It shrinks their world.
Are there efforts to address this?
Yes, thankfully. There are initiatives like Blue Whales, Blue Skies that work with shipping companies to voluntarily slow down ships in known whale hotspots. Slower speeds reduce the risk of lethal collision and also reduce engine noise. It gives whales a better chance.
So putting it all together, the sheer size of the blue whale isn't just about being big for its own sake. It's this incredibly complex outcome of evolution finding a loophole, right?
Exactly. It's a story of efficiency. Exploiting the buoyancy of water, evolving baleen to tap into an incredibly dense food source made reliable by climate cycles. It's less about brute strength and more about mastering the energy equation in the marine environment.
They really are a testament to what life on Earth is capable of, even now.
Absolutely. It shows that evolution can still produce wonders that dwarfs anything we find in the fossil record. We live alongside a true biological titan.
And it makes you realize how incredibly fortunate we are to share the planet with the largest animal known to have ever existed. But its survival feels fragile. It hinges entirely on those tiny krill.
That's the profound connection, isn't it? The fate of this giant is completely tied to the health of the smallest organisms at the base of the food web and the health of the ocean itself. Stable climate, clean water.
It really underscores the interconnectedness of it all. The biggest and the smallest, totally dependent on each other. Maybe that's the most important thing the blue whale teaches us.